Okay, these things will help us to understand the resonance, and the resonance will make us understand very complicated things. So again, there are three molecules, 1, 2, 3, and the other one is fourth. There are four molecules, but now this time this has one full positive charge, because as you see that it is trivalent carbon. This is trivalent carbon, this is trivalent carbon, and this is again a trivalent carbon, which is positive electron deficient carbons. So when you look to this molecule, it has some partial positive charge. Or let's first move to this molecule. This is simple alkane, and this is a partial positive carbon. Sorry, this is full positive carbon, because some electrons are lost. How the electrons are lost? You can say that suppose CH3, this is H and this is H, and there was some leaving group. It could be anything, okay, and it moved away from this. Okay, this is a leaving group, and the bond is broken, and the leaving group took both the electrons with itself and rendered this carbon fully positive charge. So again you will see something. This is positive charge, a very big positive charge, full positive charge. Now this carbon is electron deficient, because this has 6 electrons, and it will want very directly to complete its octet. Okay, and now I have written intentionally this positive a little bit very big, and this very big. This is a little bit bigger than this, because this is just a reference, and this is a little bit bigger because on the adjacent carbon there is an electronegative atom. This create a partial positive charge on this carbon, and this again disturbs this bond and pull electrons very little bit from it, and this poor carbon, the positive charge increases, or this become very unstable. Now it can react with something, anything, but in this case 2 chlorines are pulling electrons from this carbon, and it becomes a little bit more partial positive, and it will attract the electrons towards itself in this bond, and will make this poor carbon, which was already electron deficient, even more positive. So this is now very much more unstable, and here in this case 3 chlorine atoms are attracting electrons from this carbon, and it makes it a little bit more partial positive charge, and now these attracts the electron from this carbon a little bit more, and this is, I have just written, I want to tell you that this is more stable, so I just extended the positive charge or made it a little bit more bigger or conspicuous, that you people understand that this is more unstable, a little bit less unstable, very less unstable, and this is relatively stable in comparison to those things. Okay, just because of the inductive effect these things happen, and these things will also be very helpful for you to understand the chemical reactions. But right now we are just studying resonance, and you will understand that why I am saying. So the bigger the positive charge, okay, from the bigger I mean unstable, the bigger the positive charge, the unstable is the molecule or the carbon or this molecule. This molecule is very much unstable. This is a little bit stable than this one, and this one is more stable than these two. This is the most stable than those. So this thing, just because of this chlorine, it destroys the carbon and it makes it more unstable. The bigger the positive charge, the more unstable. So for reference, I have just written this one. This is, suppose this is the size. From the size you can sense the stability, or you can say that this group is not attracting electrons. So I have written it as such, and this group is attracting electrons, so this becomes positive more positive than this, or more electron deficient, because it has just 6 electrons present in it. 2 2 2 6, and this chlorine, just because of its electronegativity, it again pulls electron and makes this poor fellow more electron deficient than this one. And what this one, it is very unstable molecule. I don't think so that such type of thing, or intermediate, reactive intermediate you can say, or such type of the carbocation can exist. So this is stable carbocation, this is a little bit unstable carbocation, very unstable, and very unstable carbocation this is, okay, just because of the electronegativity. Why I am telling this? This will make you understand the resonance, and the resonance will make us understand the chemical reactions. Okay, now look at those molecules. Molecule 1, this is a carbocation. 2, carbocation. The third molecule, this is a carbocation. This is a carbocation. These are 4 carbocations. Now, which one among them will be more stable or unstable? There is another thing which will be clear to you in other in hyperconjugation section, which we are immediately studying after this. But now just learn that the alkyl groups are electron donors, that donate electrons. What were the chlorine and the electronegative atom? They had negative inductive effect. They just pull electron from the bond, okay. And those alkyl groups, CH3, CH3s, or again CH3, CH2s, or those groups, they are electron donors. They donate electrons, okay. They have another type of effect, and you will understand it. This is a sample. This is molecule number 1, okay. This is second. I don't think so that it is visible, so I should write it like 2. This is 3. This is 4, and this is 1, okay. The molecule 1 has nothing, 1, 2 and 3 hydrogens. This molecule has 1 hydrogen 2 and a CH3 groups. And as I told you that the CH3 groups, or the alkyl groups, are electrons donor. It has 2 electrons donor alkyl groups. This has 3 electron donors alkyl groups. Now you will learn another thing from here. What happens? The alkyl groups, what they do? They just push electrons into the positive charge, and they reduce the positiveness. As I mentioned earlier, the bigger the positive charge, the unstable the thing is. And those alkyl groups, they want to make the positiveness smaller, okay, or give a little bit electrons, push a little bit electrons into the carbon to reduce its thirst for electron a little bit. So I have written this has just hydrogen atom, and this is a big positive, mean this is very much unstable. As this is a basic course, so it is very now for this basic course you just need to learn that this is unstable, and why it is unstable I am going to explain that in the other course, which is called as the modern concepts. It has 1 electron donor group, so this positive is a little bit smaller than this positive, because it pushes a little bit electron into this carbon and make its positiveness a little bit less, or make it a little bit more stable, or decreases a little bit thirst of this carbon for electron. This has 2 electron donors, and I have written it a little bit more smaller. This has 3, and I have written it a little very small in comparison to the other. So in this carbocation, this is very unstable, or you can say when something is unstable, that is more reactive. This is again very much unstable but stable than this one, or less reactive than this one. This is a little bit stable, but again it is reactive because the carbon is electron deficient, though these two groups pushes electrons into it to decrease its thirst for electron, but again it cannot fully quench its thirst. It is the more stable among those things. Again, this carbon has a positive charge, it's not stable, but in comparison to the other things, this is more stable. This is high, the stability order is, this is very much stable, this is second stable, this is third stable, this is a fourth stable, or you can say this is unstable. So why am I saying this? Those things will help us to understand resonance. Okay, again we want to understand concept of resonance, and there are again some other things which we need to understand. These are all carbanions. Now what are carbanions? Carbon with trivalent carbon, a carbon which forms 3 bonds and has a negative charge, okay, on it. You can say non-bonding electrons on it and negative charge. This negative charge just represents that it has non-bonding electrons present on the carbon, okay. So we have 1, 2, 3 and 4 carbanions. Now there is a general concept: the bigger the positive charge, the more unstable the species is, because big positive charge, anything the big positive charge want electron more because it is very thirsty. Now the big negative charge, again it is unstable. Why? Because now it want to react with something. It is so much concentrated that it just want to attack something, okay, or it is very much, the bigger the positive charge, the negative charge, so the big it is, and it is very much available for the other things, outside things, so it can react with the outside thing, so we call it very unstable in that sense, or you can say that it is very reactive. 1 is less small negative charge, 2 is a little bit bigger negative charge carbanion. This is, I have just written a little more big, and this is the biggest. So what does this means and why? These are 3 just hydrogens, and here is alkyl group. So what the alkyl group does, it pushes electron into it, and this poor fellow has a negative charge. The electron has surplus the carbon has surplus electrons, and it want to react, and now it pushes more electrons through this bond into the carbon and make it more unstable. So it want to react more, it become more reactive or more unstable. Now 2 alkyl group pushes electrons into this thing, and it makes it even more unstable. 3 things. Now this is the least unstable or very big negative, and as it see anything it will react with it, because this is very unstable. So you can say this is very negative, very big negative, very unstable and very reactive. Why things are reactive? Reactive means unstable. They are unstable because they cannot exist in this form. They will immediately react with anything. So these things will help us to understand what concept of resonance, and the concept of resonance will make us understand the reactivities. So again, these are carbanions, okay. This is a carbanion. This has non-bonding electrons on this carbon, and just because of this a negative charge appear on it, it becomes negative. This is negative, but this has 1 chlorine immediately attached to the carbon, and you know chlorine pulls electron. It has 2 chlorine atoms, and you know chlorine pulls. This has 3 chlorines, and it pulls the electron. It has big negative, little bit smaller negative, very small negative, very small negative. Why? Again that concept: the big positive, very bad, unstable; the big negative, very bad, very unstable. Now this is just for reference to make you understand. This is the CH3. You can also write it this, but it is better to write those mention this non-bonding electron on it, okay. So it has this negative charge, this much, and it has a little bit smaller. Why? just because of the inductive effect of the chlorine. This chlorine now withdraw electrons from this carbon, the bonding electron, and it will make the negative negative charge a little bit smaller. So the smaller the negative charge, the more stable it is. Here again, two groups pulls the bonding electrons from this carbon, and now this will become a little bit partial positive, and it will make the negativeness a little bit smaller. Three things are pulling electrons from the carbon, and it will make this carbon positive, partial positive, because it will attract the electrons from it, and now it will in turn make the negativeness even smaller. So this is very stable, a little bit lesser stable, lesser stable, and this is least stable. So this is good carbanion, a stable carbanion, less reactive, a little bit more reactive than 4. The 3 is more reactive because two groups are pulling electrons and decreasing its negativeness. Just one group is pulling electrons and it decreases its negativeness. No electronegative group is present, so it is very electronegative, very unstable. So this is very strong base, you can say, or we'll study that in detail. So this is very unreactive. This is second unreactive. This is a little this is very reactive and unstable. This is a little bit second unstable. This is a little bit stable, or you can say stable or unstable when compared with those two. This is very stable when it is compared with the other. So this is the stable one, this is the second stable one, this is the third stable one, and this is the fourth stable one. Again, at the end of this, I can say you that this is again not very stable, but in comparison to those, it is stable, because it has again a negative charge present. If it is smaller, but again this thing is not as stable as CH4 molecule, because this is a neutral molecule, or CH3 molecule. This is not as stable as those molecules, or even this is not as stable as this molecule, Cl, because this is its one valency is not satisfied, and this carbon has all valencies satisfied. This is again not a stable molecule, but it is much more stable than this, and it is much more stable than this, and it is much more stable than this. So conclusion is, big positive charge, very bad. Big partial positive charge is again bad. Big full charge, very bad. Big partial positive charge, bad. Big negative charge, very bad. Small negative charge, very good. So this will make you, I'm sure that it will make us understand the concept of resonance.